Hello everyone. Alright, today I wanted to do a quick review of mole conversions. Essentially, the how to identify when you have one-step versus two-step problems. By now you should have the notes as far as everything's the two different methods I've shown you, which is how to use ratios and formulas. We're going to review that here in just a minute as well. The first thing, again, that you've got to know for mole conversions is that, first of all, a conversion factor is something that allows us to change the units on something without changing its value. Just like 1 foot is equal to 12 inches, they both are the same distance. In this case, the mole is a unit that allows us to connect three major things in chemistry. The first one being volume, 22.4 liters. Oftentimes you will see something called at STP with this. This is not something to worry about. STP only comes in later on when we talk about the gas laws. In addition, the mole is also equivalent to Avogadro's number, 6.02 times 10 to the 23rd. Remember, this is going to have a lot of different units, okay? It's kind of like 1 dozen. The units don't really matter, but the ones you're going to see most often are going to be particles. You're going to see atoms, formula units, and please watch your abbreviations on those. That's all I'll say on that. And molecules. Remember, molecules and mole is not the same thing. That is something to watch out for. Okay, and the last one, of course, is the molar mass. And that is in grams. One thing to watch out for when you're converting, and because otherwise you're going to run into the PEMDAS errors, and that is whenever you're using Avogadro's number, the 6.02 times 10 to the 23rd, make sure that you're using parentheses when you put it in the calculator. If you don't, it will do things out of order and you're going to get some very strange answers. Okay, now, how do we actually identify when we have a single step, i.e. we just put it in a formula or use one ratio, versus when do we have to do two? It all comes down to the given and wanted information in the problem. Here's where your units are going to be your best friend to tell you what to do. To start, we go through, we look for what we're given, and remember, given is numbers with units. In this case, you're given 4.25 moles in example 1. So we're starting with 4.25 mole. Remember, MOL stands for mole. What do we want? We want grams. Now, how do we know if this is one or two steps? Moles is one of the units given. If you see mole like this, moles to grams or grams to moles, etc., then it's a single step. So this one, first example, would be single step. All right, and going backwards. Well, in this case, once again, we'll read our problem. In example 2, you're given 47.6 grams. Okay? And we want moles. How many moles that is? Well, once again, this is a single step conversion. All right? The only thing we'd have to figure out is, of course, is the molar mass of the compound. In the last example, if we look at what we're given 32.5 grams of oxygen gas. And we want volume. Volume, remember, is liters. You do not see moles mentioned. This is a double step problem. That means we're going to have to use one ratio to convert to the mole. So in this case, we're going to go from grams to mole. Then we're going to go from mole to liters. So it's going to take 2 steps to get to where we want to go. All right, that is the easiest, quickest way to identify. Now, taking a look at the first example I just gave you. All right, using our ratios. We're given grams and we want volume. That means we're going to have 2 ratios we're going to need. You're going to need 22.4 liters equals 1 mole. And we're going to need the molar mass equals 1 mole for using ratios. So how do we figure out which one to use first? Well, it all comes down once again to units. I'm given grams. That means I'm going to use this first and this one second. Now let me show you how to set that up. All right, we're going to take, remember, the factor goes on one side. So we take 1 mole over the molar mass of oxygen. Remember, oxygen gas is a diatomic, so that's O2, which means it's 32 grams. 1 mole is to 32 grams, okay? As well, we got to convert to the moles. See here, remember how we had here showed you, we go from grams to moles? That means we don't know what the number of moles is. But we do know that we have 32.5 grams. All right, so what we're going to do is we're going to take this. We are going to solve it for x. And when you know it, I forgot my calculator. Go figure. All right, so we're going to do our cross multiplication and solve for x. In this case, oh, there it is. So we get x equals 1.02 when we round, 1.02 moles. All right. Why do we have to do this? Because this value is now going to be used in step 2. Now we got moles we want to convert to volume. So we're going to use our second one. Once again, so this is the first step right here. Second step is we're going to take our second conversion factor, 1 mole is to 22.4 liters, as, well, this now goes over here. So we have 1.02 moles over x liters, because now we want to solve for liters. In other words, we have to solve for the number of moles, which then we'll use in the next step, because we have to have 3 of the 4 pieces to solve for anything. We have to have 3 of 4 pieces of information. Okay? So as I said, we solve for moles first. We're then going to use that in this portion, and now we're going to solve again. And we're going to end up with 22.75 liters. Okay, again, I'm not going through each and every step, but this is an often case when it comes to stuff like this, where we have to go through and solve for one thing before we can actually solve for what we want. All right. Real quick, let me show you how to use the formula method of this. Well, we still got our factors, except The two formulas we're going to use is moles equals grams divided by molar mass, and moles equals liters divided by 22.4. Since we're given grams, we're going to substitute that in. We know the molar mass from before, so this first one becomes equals 32.5 over 32, which is going to give us, again, our 1.02. This then becomes our moles for the second problem. So now we get 1.02 equals liters over 22.4. Since it's in the denominator, remember we multiply both sides, so we get liters equals 22.75. All right, now, real quick here, I'm just going to show you the setups on this one for time purposes. I'll let you solve for yourself. But using our ratios this time around, we're given grams, and we want molecules. Again, molecules is not the same as moles. So this means we're going to use 6.02 times 10 to the 23rd. So 1 mole equals molar mass. That's going to be step 1. Then we're going to use 1 mole equals Avogadros. 6.02 times 10 to the 23rd. This will be the second ratio we'll use. Just like before, our first step is going to be moles equals grams divided by molar mass. Now, obviously we're going to need to get our formula first, then calculate out the molar mass of that. And then the second one is going to be moles equals particles. Okay, so particles, or molecules in this case, over Avogadros. Just remember, when you enter this into the calculator, make sure you put parentheses around Avogadro's number to avoid any order of operation errors. Now when you do this, the final answer, just so you can double check yourself, make sure you did this correctly, is final answer you should get should be 1.76 times 10 to the 23rd molecules. All right. Again, as a reminder, if you have any questions, please feel free to send me a remind. I'll be more than happy to answer anything you have. And good luck.